लाइफ पढ़ते हैं, ये सब अलग अलग सब्जेक्ट्स होते हैं। अगर यदि हम +1 +2 को आए तो हम अभी एक साइंस डिसिप्लिन को आ जाते हैं। अभी हम ह्यूमैनिटीज which will fall into this particular arena, and statistical mechanics and thermodynamics, quantum mechanics, electronics, nuclear physics, and so on and so forth. So there are different disciplines within physics, and once we are into physics, studying only physics, we will be confined to study these various topics. So let us go one by one. What are they deals with? Classical mechanics. So classical mechanics is the thing that we can observe. Like if I play a marble on the street, like we know that it is kancha. So when we were kids, we used to play in the roads and with this one. So what is the velocity that if I want to hit a particular another target kancha, how will we hit it? So what is the direction that I have to hit? What is the velocity I have to give? And how far I can hit the kancha? Or else if you take the lattu, so that is the spinning top. So how long you can spin? Location. So all these types of calculations can be precisely calculated using the classical mechanics. And then also moon is revolving around the earth, or earth is revolving around the sun. So all these things can be into more and more precise way. We can always get the knowledge about all these things using the principles of classical mechanics. So the gravitational pull or gravitational force of attraction that exists between any entity in this universe with any other entity in the universe. So all these things will come into the discipline of classical mechanics. Whereas once we come to electrodynamics, that is the study of electricity and magnetism, both together are known as electrodynamics. Here we know how the electricity is generated, how the bulbs are lighting, how these particular projectors are projecting the image onto the screen, so that we are all having the visual effect of what I am talking, and so on. So we have also magnetic properties, like here we have a superconducting magnet. This is a phenomena where I have here there is a gray entity. Okay, this is a superconducting material upon which a nitrogen or helium gas is poured. Okay, so helium or nitrogen gas is poured upon, so that this particular magnet will float in the air. Okay, because this particular superconducting material is a magnetic material as such, but once you pour a cool liquid onto this one, it will expel out the magnetic field, and thus the floating will happen. This is the principle of the next generation trains that people are thinking of, that is the levitating trains. Okay, and then if we have some problem in our bodies, if you want to precisely pinpoint what is the problem at what location of the body we have some problem, let's say in brain. So we have, brain is a very complicated structure of the human being. So once if there is some damage to the brain, I want to know where exactly the brain has been damaged. I cannot open the brain as such. I cannot go to the operation theater, doctor will open the skull and then check the brain. That's not the way that to deal with. So we have to externally we have to do something so that without harming the structure of the brain, we can get to know about what is wrong in the brain. So that can be achieved by using the MRI scanning that we call, actually it is nuclear magnetic resonance. Okay, at the level of nucleus, what is the magnetic field that is generated for that particular cells or organ? That is what when we lit some particular combusting material, how does this flame always goes up, or why is it having such particular irregular structure? All these things will come into the study of statistical mechanics and thermodynamics. Also the fountain. How does the liquid, that is the water, flow from these bulbs to through these holes of these pipes? All these things will be comes under the statistical mechanics. Even the rocket propulsion, how does the rocket move? So that will also come under this particular statistical mechanics. And coming to the quantum mechanics is a particular discipline where you will study the electrons, atoms, molecules, to some extent, photons, all these things. So we cannot apply classical mechanics principle or one-dimensional equations of motions that you know to for a photon that is coming from light to me. So whatever the displacement equation or velocity equation that you know currently, if I throw a ball from here to that end of the chamber, you can calculate the velocity of the ball by knowing the time of flight and distance, right? So all these things cannot be applied for these photons. So you should have different principles to handle this particular kind of entities, and this is known as quantum mechanics. So all these things are governed by not by the principles of classical mechanics, but rather it is governed by the principles of quantum mechanics. Okay, so here I am showing the picture of ions. These are single ions like oxygen and copper and calcium, nitrogen, and so on. So these are the entities which are trapped in some experimental operators like this, and then here we have just the trap of 4 ions. Okay, so it's a linear trap where the ions have been trapped, and then to trap this particular ions, you should know what is the magnetic field that you have to apply, and to pinpoint the location of each ion that you have trapped in this particular trap, where exactly you should imping this laser light. All these things can be calculated using the quantum mechanics as well as the principles of electricity and magnetism, electrodynamics, and so on. And recently people have also, so all this single point in this particular display is one single atom. Okay, so they made a movie in the IBM research. They made a movie on this one. If you search on this particular name in the YouTube, you can see they need a huge space or huge electronic equipment to handle it. You can see that this person is above this equipment. So such a big equipments are required to handle such a small entities. Okay, and lot of electronics is there, lot of optics is there. So whatever the ray optics that you study, the usual resonance, diffraction, interference, all these things, many principles are being involved in this particular experiments. So electronics, nuclear physics, and so on. I will not get into that one, but let us concentrate on how to differentiate between classical mechanics and quantum mechanics. Okay, so to start with, let us take a particular equipment. I have a gun here. Okay, so I am keeping a gun here which can fire a bullets at regular intervals. Okay, and then here I have some particular slab above the screen where when I fire this particular gun, the bullets will enter through, some of the bullets, okay, will enter through these holes. Okay, in that as I am holding the gun and shooting, all the bullets may go, some of the bullets will pass through this hole and hit the target screen. Target screen may be a wooden slab which can absorb this particular bullets that comes to it. Okay. Are you all familiar with this particular setup now? Any doubts? हमारे पास इधर एक गन है, ओके? इस पर्टिकुलर स्लैब में एक दो छेद बनाए हैं और यदि हम ये गन से बुलेट को फायर करने लगे तो बहुत सारा बुलेट्स ये छेद के मुखांतर आके इस पर्टिकुलर स्लैब के ऊपर डिपॉजिट होगा, ठीक है? यही है मेरा पर्टिकुलर सेटअप. So अगर हम बुलेट से किए तो let's say I will to start with I will close this one of the hole. Okay, so एक छेद को मैं क्लोज कर दूंगा कहीं किसी तरफ से। तो जब हम फाइल किए तो एक 5 मिनट्स फाइल करेंगे। फाइल करने के बाद जो स्लैब होता है ना, मेरा स्लैब, ये स्लैब में मेरे को ये ऐसा बुलेट्स ऐसा डिपॉजिट होता है, ठीक है। आगे और अब मैं क्या करूँगा, इस होल को मैं क्लोज करूँगा, ठीक है। और एक बार 5 मिनट में फायर करूँगा, then again I will see this particular picture. Bullets will be deposited into the slab as given in this picture. Okay. Now I take this initial setup and then I will open them both, and then this is how my bullets will be seen when I see the slab. Okay. Any doubts up to here now? So the experimental setup is clear now. So let us compare all three. So this is when hole 2 is blocked, this is when hole 1 is blocked, and this is when both the holes are open. Okay. So now I have this particular scenario for classical physics. So this is the bullet is a classical entity. You know that how much, if you just fire a bullet, how fast it will go, what is the mass of the bullet, all these things are known to you. Now let us replace this particular experiment with light experiment. अभी मेरा गन को मैं लाइट बल्ब के पास गन के बदले में लाइट बल्ब यूज करूँगा, और स्लैब को मैं ऐसा ही स्लैब रखूँगा, और एंड देन आई हैव ए हियर एक फोटोग्राफिक प्लेट रखूँगा। फोटोग्राफिक प्लेट मतलब हमारा जो एक्सरे लिए तो हमको प्लेट मिलता है ना, वही है फोटोग्राफिक प्लेट, वैसा ही प्लेट रखूँगा। हम इधर 2 होल किए हैं, वो बहुत वो उसका जो डायमीटर होता है बहुत कम रहता है, ऑलमोस्ट इक्वलेंट टू द वेवलेंथ ऑफ द लाइट। Okay, you cannot have a big holes just for this small thing. This should be comparable. The size of the hole and then the wavelength of the light should be comparable. That's what is the condition. So now I will do the same experiment. First, what I will close? What do I do? So let me close one of the hole, and then what I will get is this one. Okay. Then I will close the first hole and then do impinge light for 5 minutes, and then develop the photographic plate, and then I will get this. This is the result. And when I have the both holes open, then I will get this is the thing that I will see. अगर बुलेट्स को छोड़े तो मेरे को जैसा डॉट्स एक पर्टिकुलर स्पॉट था, उसके अगल बगल में बुलेट्स डिपॉजिट हुआ था, मगर मैं लाइट छोड़ा तो ये क्या है, यूनिफॉर्मली फोटो प्लेट के अंदर पूरा अंदर में यूनिफॉर्म बैंड्स आ गया। क्यों नहीं, फोटोन जैसा बुलेट्स जैसा एक जगह था, उसके अगल बगल में फोटोन आए हुआ मार्किंग नहीं है, मगर हमको ऐसा पैटर्न आ रहा। ओके, so this is something strange, right? So why it is not coming in the same way as I got this one? I should have got it. If I have with bullets I get this one, why not with light I will get this one? Okay, these are the actual experiments. So now what I will do is I will take an electron. You know that electron is a particle, right? So you may say that here, you may say that the light is a wave, so therefore I may have this one. But electron is a particle. Everybody agree? पार्टिकल है ना, वो जो न्यूक्लियस के रेवोल्यूशन करता रहता है। तो अभी मैं एक इलेक्ट्रॉन गन लूंगा, वो इलेक्ट्रॉन गन से इलेक्ट्रॉन्स का एजेक्टेड हो। अभी मैं सेम ये 2 स्लिट्स रखूंगा और उनके मुकाम पर ये इलेक्ट्रॉन को छोड़ूंगा। So I can have to have a detector. I can have two settings. One is movable electron detector. ये जो detector है उसको मैं continuously move कर सकता हूँ. नहीं तो arrangement of electron का electron detectors को अभी arrange कर सकता हूँ. दो ही possible है. Let's take movable electron. मैं एक 20 मिनट इलेक्ट्रॉन गन को ऑन करूँगा. ऑन करके पहले स्लिप 2 को क्लोज कर दूँगा. So then I will get like this. Okay. Now again I will go to the previous setup. I will open this one and then close the S1 slip. Then I will get this particular setup. Okay. Now again what I will do is I will open the both and then do the experiment and I will get this one. So you started with electrons as a particles, but we are seeing the image which is similar to our light, right? क्या हुआ अभी तक 3 एक्सपेरिमेंट में? पहले एक्सपेरिमेंट में इलेक्ट्रॉन्स लिया हमको दोनों रंग को जब ओपन किए तो ऐसा आ रहा है इमेज. लाइट को किया ऐसा बैंड था. इलेक्ट्रॉन को किया फिर भी बैंड सी आ रहा है. यदि हम इलेक्ट्रॉन्स को पार्टिकल बोले तो ऐसा रहना है मेरा इमेज.